We have a cylindrical tank. The volume of the tank is given as 10 CFT, and the surface area A is including the top and bottom surface. So surface area is given by this expression, where R is the radius of the base and H is the height, and this one is of course the area of two surfaces, so pi r square plus pi r square, and this one is the area of um, the side, so the cylindrical 2 pi r h, the area of the cylindrical surface. So we have to show that A is 2 pi r square plus 20r. So let's start with the expression that is given. A is equal to 2 pi r square plus A is equal to 2 pi r square plus 2 pi r h. Now we can see the one we have to prove here. This expression of A does not have any h there, and the volume is given. So we know the volume of the cylinder is given by this expression pi r square h, and that is 10 CFT. So we can write h as 10 over pi r square. So we need to substitute the h in this expression. So let's do that, and 2 pi r square, and here 2 pi r, and instead of h we can write 10 pi r square. So it becomes, the pi gets cancelled, 10 into 2 gets 20, and that's r. So this is the expression that we needed to get. This is what so we have done that. Now we need to show that A has a minimum value, and for what value of r? It says show that A has a minimum value and find the value of r for which A is minimum. So let's first try to show whether A has a minimum value. So when A is minimum, the area is minimum and the variable is r here, so dA and dr, dA over dr will be 0 when A is minimum. So if we differentiate this term, it becomes 4 pi r. I am differentiating this expression, so it's 4 pi r minus 20 r square, and we equate it to so this is our dA over dr, and we need to show that this one has a minimum first. So in order to do that, what we can do, we can find the second derivative and look for the sign there. So but before that we need to find for which value of r this A becomes minimum. So what we do, we equate this expression to 0, and it becomes 20 is equal to, so I multiply by r square both sides, so 4 pi r cube there. So r cube is 4 pi 20 over 4 pi, which is 5 over pi. So r is cubic root 5 over pi. So this is the expression of r. This is the value of r for which A can be minimum or maximum. So we have to see whether that's minimum or maximum. So in order to do that, we look at the sign of the second derivative. So we do this one, dA square over d square A over dr square. So we differentiate this expression again, this one, and this time it becomes 4 pi, and the second term becomes positive there, so it's 20. So 20 times 2, negative 2, and r cube, r to the power minus 3, so it's r cube. So it becomes 4 pi plus 20 into 2, so that's 40 over r cube. Now what we see here, if we write this r 3 5 over 3, if we plug in this value in this expression, we will essentially get a positive value because there is no negative sign there. This is a positive and this one will be positive, because there is no negative sign. So dr square is greater than 0 for this r. So of course, since this is greater than 0, of course this value is minimum. So that part is proved, and then we need to that's what we need to do actually. So we have found the value of r, and for this value for which the value of a becomes a minimum. So that's the result there.